Welcome to Study Loop.
This is chapter 21, problem number 68. We have this circuit B on the figure, and it consists of a resistor with 520 ohms of resistance, and the filter capacitor has a capacitance of 1.2 microfarads. Will this capacitor act to eliminate a 60 Hz AC but pass a high frequency signal of frequency of 6 kilohertz? So we have two different frequencies that we're going to check whether or not this capacitor is attenuating a certain frequency or not. Now, in order to figure that out, to check this, we need to figure out the voltage drop across the resistor, right? So the voltage drop across the resistor is the current times the resistance. However, the current here, there's the impedance of the system, right? So the impedance of the system, the input voltage divided by the current is our impedance, right? So if we want to write this equation in terms of the current, then it's going to be input potential divided by the impedance. So let's plug this in the Ohm's law that we wrote. So the input potential divided by the impedance times the resistance. Now let's remember what impedance is. For this case, this is an RC circuit, so we're going to have R squared plus X, the reactance of the capacitor, right? Where we know that the reactance of the capacitor equals to 1/2 pi F capacitance. Now, putting everything back in the mean equation, then the input power times the resistance divided by the impedance, which is R squared plus 1/2 pi F C squared. Now, what we're going to do, we're going to use this equation to figure out the potential drop across the resistor for these two frequencies. And depending on our answers, we're going to be able to say whether or not either frequency is attenuated. Now, let's go on a new page. All I'm going to do right now is to plug in the values that are given to us in the problem. So, for the case of 60 hertz, the potential drop across the resistor then is going to be equal to input potential is 130 millivolts. Let's convert that to volts times 520 ohms of resistance divided by, again, 520 ohms of resistance squared plus 1/2 times 3.14 times 60 hertz times the capacitance, which is 1.2 times 10 to the power of -6 farads, but we're going to take the square of this entire term, still under the square root. So then our answer to potential drop across the resistor is going to be 29.77 times 10 to the power of -3 volts. Now, if we apply this time, instead of 60 hertz, if we put here 6 times 10 to the power of 3 hertz, we're going to recalculate everything, right? Because this is the new frequency now. So 130 times 10 to the power of -3 volts times 520 ohms divided by square of the resistance, 520 squared plus 1/2 times 3.14. Now for frequency, we have 6 kilohertz. So that we have 6 times 10 to the power of 3 hertz, and the capacitance. So when we take the square and the square root of this, we're going to find the potential drop across the resistance as 129.88 times 10 to the power of -3 volts. As you can see, when the frequency is greater, this capacitor allows the higher frequency to pass, and it attenuates the lower frequency, which in our case was 60 hertz.